Bismillahirrahmanirrahim. Good morning ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. What if I tell you that we can save time to fertilize the rice field? The concept that I would like to tell you today is about how we can help a farmer in fertilizing the rice field by manufacturing a slow-release fertilizer from natural-based material. My name is Bayu ISHARTONO, and this research publication is co-authored by Mrs. Indriana Kartini and Mr. Suyanta, with the title of publication is Effect of Zeolite Clay Ratios on the Formation of Zeolite Clay White Cement Composite Cylinder as an Encapsulant of Urea Fertilizer. This paper is presented in the 6th International Conference on Science and Technology 2020. This presentation is divided into 4 parts, namely Introduction, Experimental Section, Results and Discussion, and the last is Conclusion. Ladies and gentlemen, as we know that farmers use urea as the fertilizer because it has high nitrogen content, it's about 46%, easy to use, and relatively not expensive. However, compared to our research idea, conventional urea fertilization has some weaknesses, such as can be consumed in excessive amounts, may cause problems in agricultural ecosystem, such as soil acidification, until nitrate accumulation in groundwater. Slow-release fertilizer is a good innovation which can reduce the rate of fertilization release and increase the efficiency of fertilizer nutrition uptake. And then, this study aims to maintain the initial form of urea fertilizer granules to be encapsulated using physical barrier. We use natural zeolite because zeolite is abundant in nature and has a potential to be used as physical barrier. We also use natural clay is added to zeolite, resulting in a better agglomeration character to the aluminosilicate framework and give an impact in increasing the mechanical strength of zeolite clay composite. However, the zeolite clay composite shows hydrophilic character and causes low resistance in the aqueous medium. So, to overcome this problem, we use white cement because white cement results the hydration and pozzolanic reaction. Both reactions produce a strong and compact composite and can rearrange the microstructure of the composite. As a result, the composite we made has a high physical resistance in aqueous medium and also a high mechanical strength. Therefore, a modification using white cement in zeolite clay composite is expected to act as an encapsulant of urea fertilizer and also act as a slow-release fertilizer. Then the material used in this study include natural zeolite, natural clay, white cement with composition of 3 calcium silicate is about 72%, D-calcium silicate is about 11%, 3 calcium aluminate is about 9%, and the last is tetracalcium aluminoferrate is about 0.5%. The prepared composite was also characterized using infrared spectroscopy, and then X-ray diffractometer, compressive strength test, and water absorption capacity test. To prepare the composite, a 5 gram of mixture of zeolite clay with a ratio 0.023 until 7:3 was mixed with 20% of white cement and 4 ml of water in a glass beaker. The mixture was mixed homogeneously and printed using homemade mold to be a composite. Ladies and gentlemen, you can see the infrared spectra of natural zeolite, natural clay, and white cement and prepared composite in figure A. Spectra A and B refer to infrared spectra of natural zeolite and clay. From this spectra, we get information about silanol or aluminol stretching vibration, then hydroxy stretching and HOH bending vibration of water molecule in zeolite clay, TO4 stretching vibration, and then OSIO or OALO symmetrical stretching vibration in zeolite, and the last is SIOAL bending vibration of clay. Then spectra C refers to spectra of white cement. From this spectra, we get information about hydroxy stretching vibration, carbonyl group of calcite, SO stretching vibration of sulfate groups in gypsum, OSEO asymmetrical stretching vibration of tricalcium silicate and tricalcium silicate, and the last is MO, with M is iron or aluminium symmetrical stretching vibration and bending vibration of tricalcium aluminate and tetracalcium aluminoferrite. The last spectra is spectra D, refers to spectra of resulted composite. From this spectra, we get information about hydroxy stretching and HOH bending vibration of calcium silicate hydrate. And then for X-ray diffraction analysis, diffraction pattern of A refers to diffraction pattern of natural zeolite that contain morganite, clinoptilolite, and quartz. The morganite mineral has ability to exchange ions and high affinity adsorption. The diffraction pattern of B refers to diffraction pattern of natural clay that contain montmorillonite, kaolinite, cristobalite, illite, and quartz. The montmorillonite gives the ability to absorb water, so it is easy to be plastic and can be applied as a natural binder. Diffraction pattern of C is diffraction pattern of white cement. From this diffraction, we get the presence of tricalcium silicate, dicalcium silicate, tricalcium aluminate, and the last is tetracalcium aluminoferrite, gypsum, and calcite. And the diffraction pattern of D refers to diffraction of prepared composite, and we get information about calcium silicate hydrate in the form of tobermorite and chenite mineral. Chemical interaction prediction in the composites depend on the hydration and pozzolanic reaction. In hydration reaction, both calcium silicate hydrate and dicalcium silicate hydrate react with water to produce primary calcium silicate hydrate and calcium hydroxide or Portlandite mineral. Then, in pozzolanic reaction, the calcium hydroxide reacts with aluminosilicate compound of zeolite clay composite to form secondary calcium silicate hydrate. This calcium silicate hydrate affect the physical strength of composite. In our study, we analyze the effect of zeolite clay to clay in the composite. Okay. Based on compressive strength test in this diagram, we can conclude that the decrease in the compressive strength from the composite with the zeolite clay ratio from 0 to 3 until 7 to 3 is caused by an increase in the ratio of zeolite contained in the composite. We try to explain this phenomenon based on hydration and pozzolanic reaction in the composite. In the hydration reaction, with the mass of white cement is fixed and more water molecules bound in the zeolite's framework, so it could produce a fixed amount of calcium hydroxide or Portlandite mineral or CH. This product in here is act as limiting agent. Then, in pozzolanic reaction, when calcium hydroxide is limiting agent, so calcium silicate hydrate produced was also limited. It caused a decrease in mechanical strength. On the other hand, Based on water absorption capacity test, we get a trend of increasing value of water absorption from solid clay ratio from 0 to 3 until 7 to 3. It can be explained that high affinity of active site from composite make it more hydrophilic. So, the more water molecules found in the active sites, the greater the water absorption capacity of the composite. Based on the infrared spectra of all variants of the composite, there was no significant differences in the absorption band at 3,400 and 1,600 as an indication of the presence of calcium silicate hydrate. Meanwhile, the diffraction pattern in figure B, higher intensity of the martenite suggests the mineral in natural zeolites do not react completely with the calcium hydroxide in pozzolanic reaction. Ladies and gentlemen, as a conclusion, we conclude that an increase in the solid clay ratio has resulted in a decrease in the compressive strength and also an increase in the water absorption capacity of the composite. Also, the authors are grateful to the Ministry of Research. For the closing, the authors are grateful to the Ministry of Research and Technology or National Agency for Research and Innovation Indonesia and Universitas Gadjah Mada for PT-UPT undergrad with this number. Okay, ladies and gentlemen, that's our presentation about our study. This is our functional coating material research group, and this is also our slow release fertilizer research group. Thank you for attention. Good morning and wassalamualaikum warahmatullahi wabarakatuh.